Hello, everyone. My name is Blain. I'm been farming in southeastern Saskatchewan for a little over 45 years now, I guess. So I don't consider myself an expert in any way, but I guess I do consider myself a reasonably keen observer. And I'd like to share some of the things that I have learned over the last 45 years, I think, and to just kind of tell you a little bit about what I think we're doing as society and why I think we're doomed to failure unless we make some radical changes. So the experts, ecologists, people like that are telling us we're living in the 6th great extinction right now. And I don't know whether that's accurate or not, but I'm going to share a couple observations. I've been a keen watcher of birds and migrations for many years. I've lived on the same spot. And things like the white-throated sparrow and the Harris sparrows are very entertaining birds to watch every spring and fall as they move north and south. And over the last number of years, their numbers are definitely going down. So what that means, I'm not sure. I remember 20 years, 30 years ago, when you go for a drive in southern Saskatchewan at sunset or into the dark, used to, in June and July, you'd have to stop every 20 or 30 miles. And you'd have to clean your windshield because there would be so many bugs hitting it. It was just like rain at times. And the windshield wipers weren't probably as good then, but you just couldn't keep them off and your windshield just kept getting stickier and stickier. Nowadays, you can drive anytime and you never have that. You still get a few bugs once in a while, but nothing like we used to. And when we think about the biomass of insects, I've heard experts say that 70% of the biomass has disappeared. And this is an anecdotal thing, but that's what I observe in the part of the world that I'm familiar with. So it makes me nervous that maybe these experts are correct. The other thing that I do notice from my observations is that the growing season, I'm a farmer, so I'm very interested in how things grow. We have gained probably 8, 10, 15 days of growing length since I farmed in those 45 years, that our seasons are that much longer. So that's quite a startling change in a relative short time. So, the experts tell us the world is warming up. They tell us that what we hear all the time is that carbon is the problem. However, I'm not totally convinced that if we just focus on carbon only, that's going to be the solution. So what I want to talk about is what I think are possible solutions, and share some of that with you here in the next little while. Just trying to get my slideshow to go. I think you should have it there now, Michael. Is that correct? Can you see it?
Yep, I see it. It's good. Okay.
So I guess the point I want to make is whether we have a crisis, whether it's changing, I'm going to call it uncertainty, because as I said at the beginning, I am not an expert in any way. But as I listen to the news media talk about, for 60 years now, we've known about that CO2 is making changes to our atmosphere. And we talk about limiting mainly fossil fuel emissions, and they're still going up. We haven't done a thing in 60 years. So, I think we maybe have it wrong. So what I want to discuss here in the next few minutes are carbon dioxide, how the earth cools itself, what regenerative agriculture's role could be in this, and what the soil carbon sponge is. So bear with me as I go through this little presentation. So I think we're all familiar with the Keeling curve. Dr. Charles Keeling in 1958 built an observatory on Mauna Loa in Hawaii and started to measure the CO2 levels in the atmosphere. At that time, 1958, it was 280 parts per million, and today it's well over 410. And we say, oh, it's because we burn fossil fuels, and I have no doubt fossil fuels do contribute. But what we don't often think about is that every single year, the curve does this. So this is the big curve I just showed you. It goes along like this, slowly going up, 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 up. But every single year, we have a massive oscillation in that curve. So it's approximately 130 billion tons of carbon goes up every year, and 120 billion tons of carbon gets sucked back down. Well, that's what most people don't realize. So this is a natural process. So we have a huge die-off every fall, and all of the carbon that's in the plants, etc., the green growth on the planet is released. So that goes up into the sky, into the atmosphere. And then as we get green up in the spring, we start to suck it down. So obviously, when you take 130 minus 120, we're 10 billion tons short. And that's why we're having warming. So the question then is, why do we have a 10 billion ton shortfall? And that is a very, very good question. And there's many reasons that are possible. But Dwight Eisenhower, the former president of the United States, says when we focus on a problem like this and can't solve it, we need to enlarge the problem. I believe he's absolutely accurate. So we need to look at this a little bit different. So obviously, if we want to get to zero, which is the current political statement, we're going to be at net zero, we'd have to increase our drawdown by 10 billion tons a year. So that gets us to zero. However, that doesn't solve the problem because we still have a legacy load up there. So we'd have to remove 20 billion likely to start making any difference. Now, various experts have said we have limited time, maybe 10 years, 20 years, no one knows because we've never been in this situation before. But many, many experts believe that we don't have 60 more years to play around and think about it. So this creates a bit of a problem for all of us in society. So let's look at the problem slightly different. So here we have the watts of energy that come from the sun every day. So every square meter on Earth receives 342 watts on average. Obviously at the poles is less in the winter, but on average it's 342 in. And by the various cooling mechanisms of the Earth, 339 go back out or re-radiated back into space. We always focus on carbon and carbon dioxide when we talk about climate change. But what most people don't realize is 95% of the heating and cooling of our blue planet is water vapor. So why would we focus on a minuscule gas like CO2? Let's focus on the big one, which is water vapor. So the question then is, can we increase cooling by 1% or 3 watts per square meter? That is the question. If we could do that, we could likely solve the problem. So I want to spend a minute looking at what happened or what has happened to the surface of our planet. About 21% of the mass of the Earth is dry land. It's about 14.9 million hectares. Or billion hectares, sorry, and 13 of that is roughly functioning ecosystem, forests and rangeland. That's how it was 10,000 years ago. About 10,000 years ago, our ancestors settled down and decided it was better to grow food than chase it. So hunter-gathering systems slowly disappeared in most societies, and we began to be agrarian. So over that 10,000 years, we've taken the 13 billion hectares of functioning ecosystem and we've changed it to what's on the right-hand side. So we took 8 billion hectares of forest and made it to 3.5 billion hectares of forest. We took the 5 billion hectares of rangeland, it's down to 4 billion now. And we have a new category called cropland, which is 1.5 billion. And we created one more new category called desert, which is 4 billion hectares of desert that agriculture has created in the last 10,000 years. So when we think about the heating and cooling of our planet and water vapor, this has phenomenal effect on how the planet functions. So if we want to truly solve this, I think this is where we can make maximum gains. Make sense so far, Michael?
Yeah, it does. That's great. You know, it's just a nice way to, you know, wrap your head around what have been. And again, it's not about judgment or saying, you know, good or bad. It's just, this is our reality. This is how we've modified the planet. in the quest to just try to feed ourselves.
Yeah, I agree. We spend so much time focused on CO2 and blaming people, fossil fuel industry, whatever, that we forget about the big picture. So that's, I think, what I've learned over the last number of years is that we need to focus on understanding how our planet truly functions, and just focusing on CO2 will never understand it. So this pretty graphic here, I think, and the question is, which is cooler? Well, I think we all know from being barefoot in the summer, you know, you put your foot down on a bare surface and you go, ouch. You put your foot down on grass and it's cool, very nice, pleasant, even on a hot day. And so I think we all know that. And then you think about the fact that we've created 4 billion hectares of desert on our planet. Well, that has phenomenal heating effect. That is just a huge, huge game changer in how the climate functions when you have 25% of your dry land is now desert because of agriculture. So that's a pretty frightening statistic. So let's look at some of the cooling processes that the planet uses to attempt to re-radiate out that 342 watts of energy that come in every day. So one of the first mechanisms is transpiration. So we all know about photosynthesis in green leaves. It captures the energy from the sun and creates food for us, or cows, or whatever it is. But what we don't often think about is that one of the byproducts of photosynthesis is water. And so that water exits the stomata of plants. It's a liquid inside the plant. It gases off as it goes out, and that creates a tremendous cooling effect. In fact, if we do the measurements, the physics, it works out to about 85 watts per square meter of energy is cooled or reflected back when that water vapor comes out of the plants. So if we increased transpiration or photosynthesis by 5% on our planet, there's our 3 watts per square meter right there. That's pretty simple. Now, obviously, you don't get anything for free. So as that energy or that water vapor floats up into the sky, as it recoalesces into water vapor, there's heat created in that process. But now we're up 3,000 or 4,000 meters up in the sky. And so that heat then re-radiates back into space. So the next major cooling system the Earth uses is albedo. And every one of us that lives in the northern climates understands this really well. In March on a nice warm, say plus 10 degree day, if you're outside and you're standing on a bare patch, it feels pretty darn nice and warm. But you step over where the snow hasn't melted yet, and boy, it's kind of cool. You feel the difference right away. And what's happening is the white surface of the snow is reflecting the heat back into space. It's called albedo effect. And so clouds also have an albedo effect to the tune of about 120 watts per square meter. Approximately 50% of our planet is covered in cloud at any one time. So by increasing transpiration slightly, by greening a little bit of that bare land, or making what we do greener, all we have to do is have a 2% increase in our clouds, and there's our 3% or 3 watts per square meter. So once again, that's relatively simple to do. So those are two natural processes that happen every day that we can use to solve our problem. All we have to do is get better at doing agriculture, and these two things will happen. So then we move into our next part, which is regenerative agriculture. So I've kind of made a little graph here, call it A, B, C, and D quadrants. And the little bit of scribbling there in the center is supposed to represent leaves and roots. So on the A part of the graph is agriculture. We need to have food. If we're going to live on the planet, obviously we got to eat something. So that's what agriculture does, is provides food for us. So the top right hand, the B part there, is what happens to the carbon molecules. So we have the ability, when we do agriculture, we can burn those carbon molecules off in the process of producing food and put them back up into the atmosphere. And so oxidization does that. If we just leave the plant sit there and oxidize on the surface, they'll go back up into the sky. We can till the soil. That introduces oxygen in, creates very rapid breakdown, and we can send that carbon that was stored in the organic matter back up into the sky as CO2. Using high rates of nitrogen fertilizer causes breakdown in organic matter, and that again sends CO2 back up into the sky. Some of the biocides that are used in modern agriculture, they stop some of the microbial life, which again sends CO2 back up into the sky. And using cattle improperly, or sheep, or any kind of animals, letting the system get overgrazed, puts carbon back up. So that was what we have done with traditional agriculture. And that's why we saw on that graph a while ago, we've created 4 billion hectares of desert, because we have taken the carbon out of the soil and put it back up into the sky. So what regenerative agriculture is all about then is sequestering the carbon into the soil. So what we need to think about, and this wasn't widely known until maybe the last 20 years, is that we have these leaves here, and the sun hits those leaves, creates photosynthesis, which one of the products of photosynthesis is sugar. So that sugar then goes down into these roots. And what happens with that sugar is it actually leaks out or exudes out of the root into the area right around the root called the rhizosphere. And that seems extremely wasteful. But what the plant is doing is it's feeding the microorganisms in the soil. So the plant has created this symbiotic relationship over time with the organisms in the soil. And so the plant feeds them, but then the plant says, hey, you just got a free lunch. I want something back. I need some water, or I need some zinc or boron or copper, or whatever it is the plant needs. It's sending signals. And we're learning as we get more into regenerative agriculture that this is extremely complex. It's called quorum sensing, and there's all kinds of connections between the microorganisms, that all the plants in the system, and they're constantly communicating underneath. And sugar, carbon, is the mechanism of exchange. And so what regenerative agriculture does then is fosters this. It's changing the farming slightly so that instead of doing the B, where we're oxidizing the carbon back up into the sky, we're sequestering it into the soil. And that is critical for our long-term success. So in real simple terms, humanity's fate depends on whether we can get the B and the C correct. We've got to minimize the B, maximize the C. And as we do that, then on the bottom left, we have the D, which are the dividends. And so what happens then is we begin to sequester carbon into the soil. Every gram of carbon that we can put in will hold another 8 grams of water. We all know that the climate changes as we warm, so we don't have as regular rainfall as we used to. So if we can hold more water in our soil, that gives us tremendous resilience as farmers. Another interesting thing about carbon is it makes our food more nutrient dense. You've probably heard stories, and you look around, if you go for a walk in a mall or in a city, you notice that many of us aren't particularly healthy looking anymore. We have obesity, we have diabetes, we have cancer, ADHD in our kids. We have all sorts of wonderful health problems that we didn't have several generations ago. And part of that is because the food that we're producing with the traditional industrial agriculture doesn't have a lot of nutrient density in it. Because we have to have that symbiotic relationship between the microbes and the plant roots. That's what's critical. That's what gives us nutrient density in our food. So regenerative agriculture focuses on how we make that work better. So we get increased resiliency, the roots go deeper, and lo and behold, productivity goes up. So it's win-win for everyone. So that's the part about how regenerative agriculture can help solve this particular problem of climate uncertainty.
Yeah, that's just so cool, isn't it? That your goal may be to remove CO2 out of the atmosphere, right? That important job. But one of the interesting unintended consequences can be better food.
Yeah, I know it's
Just
you know,
wonderful,
when we
very
start to
hopeful.
get, yeah, when we start to get it all together and understand the big picture, look at the whole, understand how
Right.
the earth functions. It's incredible how simple the problems become. We just have to understand it and start to do it on a big scale. So my answer then is my understanding is that, can we cool the earth? Absolutely, I think we can. If we just increase regenerative agriculture worldwide, maximize the sea, or the sequestering of carbon into the soil, and minimize the exiting of carbon from the soil, it always will function. Carbon always goes in and out. That's normal. But what we have to do is maximize the sequestration and minimize the burning of it, the oxidizing of it. And so the cloud cooling, the albedo effect, and the transpiration only work if the soil carbon sponge is functioning. And that's what we have to understand. So it's all goes together here. So I want to just illustrate the soil carbon sponge a little bit. So if we think about a particle or a rock, the various particles of the rock are really tightly held together. It's dense. You know, you pick a rock up, it's heavy. It's not what you'd think plants would like to grow in. But at the beginning, back 420 odd million years ago, when life began on Earth, it started in the sea first. But what happened was the ocean was running out of nutrients, so they needed to have some mechanism to get some of those nutrients off the land. So various creatures started to creep out. One of the main ones was mycorrhizal fungi. And so they came onto the land, and they had the ability to start to take those rocks apart and take some of those minerals that you see there, the copper, zinc, molybdenum, phosphorus, whatever it was, and then take it back into the sea. Well, it wasn't very long before that was highly inefficient. So they figured out, well, maybe they may as well live on land. And so one of the things that started was algae started to form, which you still have today on the side of your house or whatever, that are constantly decomposing things, taking them back down. But the process of all of this is that carbon was left behind. And think of carbon like bed springs. So what it does is it opens up the space in between. So instead of having those particles tight together like rock, we now have these springs kind of holding those particles apart. Pardon my real simple analogy here. But what that does then is let air and water and roots and all those things go in, and we call it soil. And so what's happened then over the last 10,000 years of farming, this process happened naturally from 400 odd million years ago until we started agriculture. So there was tremendous carbon stored in the earth's soils. We had these bed springs all over the world. And then what's happened is we've began tillage primarily, and now later with our more modern approach, we use various biocides and synthetic fertilizers and all those things, which have really speeded the process up. Is we have farmed the carbon out. We've taken the bed springs back out. And I can illustrate this really simply with this particular picture. Here's the same soils. One on the left-hand side, you can see there's no black color in it anymore. So that tells us that the carbon is gone. And if we look, you can see that 10% and 15% here. So 25% of this soil is space. And soil should have lots of space in it. We look on this side where the carbon is still here. We have 40% air, 20, 30%. So 70% of this soil is nothing, space, it's voids. Look at the organic matter level, 10%, 1%. And so what we're able to do with our modern agriculture is we can very quickly take what's on the right-hand side and take it to the left-hand side. Very quickly. Within, on my farm, my grandfather came 120 years ago. And, my son is farming that farm now. And we managed to, in just over 100 years of farming, we took it from 12% when it was at settlement to it was down as low as 2%. When I finally figured all this out, I was kind of a slow learner. It took me about 20 years of farming to figure this out. I started farming regeneratively about 25 years ago. And I now have mine back to, the last test I took was about a year ago, and it was back to 7.5%. So with regenerative agriculture, we can take it this way and we can go this way. With industrial agriculture, we can take it this way and go this way. The choice is totally ours, what we want to do. But if we go to the right-hand side, obviously, this right here is organic matter or carbon. 58% of organic matter is carbon. And so that's absolutely critical. Our big problem is CO2 up there in the atmosphere. We want to get more of it down in here. When it's down here, it does phenomenal good to our soil and our food and everything else. When it's up in the sky, it causes problems. So we just have our carbon in the wrong spot. We've taken it here, put it up. Here we've taken it and put it back down. And
that's an interesting point. Many don't understand that significant portion of the CO2 in the atmosphere causing trouble was actually carbon in our soils that's now been, one way or another is converted to CO2 and is, so we just need to take that carbon that was in the soil now as CO2, put it back in the soil.
Yeah. You do the math and just say in Western Canada, the average carbon was probably 8 to 12%, depending on where you are, the organic matter levels. And most soils now and most conventionally farms are anywhere from 2 to 4%. Just do the math and how many tons of carbon that is. It just blows your mind. We like to blame fossil fuel for it all, but it's way bigger than fossil fuel. And that's what I'm saying in this is that right. We have to look at the big picture here. So here's the next part of the equation is that these little creatures here get blamed. We hear it all the time about how they're part of the whole problem. But when you think about how Mother Nature functions, if we go roughly, say, if we split North America with the Mississippi River, if we go on the east side of the Mississippi, it's called, it's a more moist environment. So there tends to be more constant humidity, a little bit higher rainfall. And so we think about what was there before we came along, and it was basically forest. The entire, in fact, I've read books that say that a squirrel could go from the Atlantic to the Mississippi, the whole way, hopping from tree to tree. That's a lot of forest. But anyway, so every fall, it gets cold, the leaves fall to the ground, and there's laying on the ground. If you went back by next August, you wouldn't find any leaves left. They've totally recycled. The nutrients that were in those leaves have recycled. And so the question is, what made that recycle? And basically, to get vegetation to recycle, we need several conditions to be met. We need to have warm, wet, and dark. And obviously, because it's a more moist environment, less brittle, that condition was achieved at the surface of the ground. We didn't have to go out there and cultivate it or disc it or anything like that. It happened all on its own. That those leaves decomposed, recycled every single year. So if we go out west now to the drier parts, the more arid, the more brittle parts of the world, and think about what the predominant vegetation was, it was grass. Because it's drier, trees tend not to grow as well. There was trees here and there, but generally it was an open prairie or plain, and the predominant species on the plains, it was very complex. There was lots of species, but the dominant species was grass. Now, there's a lot of different types of grass in the world, but there isn't one single grass that loses its leaves. Leaves stay on grass. So how does that cycle? Here we have a relatively erect plant. You can see it standing up there. How does that grass recycle? So it's drier, so we can't achieve warm, wet, and dark at the surface of the earth. So that grass will oxidize. And over time, if that grass doesn't have something happen to it, it just slowly decomposes by air and wind and a little bit of rain once in a while, and it goes back up into the environment, back up into the atmosphere. So what nature did then is it developed a really elegant solution. They're called ruminants, mobile biodigesters. And so their function in the ecosystem is that warm, wet, and dark that happened on the east side of the Mississippi now happens in the rumen of the cow or sheep or goat or giraffe or elephant or whatever species you want to look at. And so that they are able to consume this vegetation and put it back into a form that recycles very quickly, called cow manure. So when we look at just refreshing our memory again about what we had 8 billion hectares of forest and 5 billion hectares of rangeland before agriculture. Today, we still have about 4 billion hectares of rangeland. It's too rough, too dry, too rocky. It cannot be changed into cropland. And so, when you have a significant chunk of your surface of your land is range, you better make sure that you're doing something to make this part of this significant part of the ecosystem cool. You want to have it green. You don't want to change it to this. And that can happen really easily. So I just want to illustrate that with this picture. So on the left-hand side of the picture, this picture was taken on July 16th on my farm. And you can see it's getting pretty mature. So those plants are no longer actively growing. They're not transpiring anymore, so they're not doing that cooling anymore, at 85 watts of cooling. That's not happening on the left-hand side. But on the right-hand side, where the truck is sitting, you can see it's much greener, it's actively growing, it's photosynthesis happening, transpiration, cooling is happening on that side. And so that's what animals can do. Is so that they took that grass 60 days ago, they ate it off, probably July 16th, so it would have been May 16th roughly. They ate that grass off, and that gave that grass a setback. And so now it's actively growing. And we can do exactly the same thing on the left-hand side by grazing that again, or grazing it for the first time now, getting that material off, and then those plants get another spurt and grow again. So that makes a huge, huge difference when you think about how the planet functions. Now, in some of the drier areas, you may not be able to graze it twice a year. You'll only be able to graze it once. But if it isn't grazed, if it just stays like this, next year, this is still erect. It's not recycling. Plus, the next problem you run into is that all of that material shades the ground. So the new growth that starts in the spring doesn't get any sunlight. So it has a difficult time to emerge. And over time, you get 2 or 3 years of growth built up like that, your plants start to die. And the other thing that you face is you have a huge amount of vegetation like that, is you get fire. And fire puts a huge amount of carbon back up. Instead of having that recycle, now that fire is just burning it and it's going right back up into the sky. So these animals are absolutely critical. And so you look at the planet, in a view like that, and the amount of deserts we're creating with agriculture, it's phenomenal. It's growing at a very, very rapid rate. The United Nations is, there's a whole committee of the United Nations concerned about desertification. And so we have to figure out how to regreen. And the only way we can regreen in some of these drier areas is with ruminants. So this is what we hear. Oops, sorry, Michael.
Well, just to repeat some of that is, on a healthy rangeland, the tool to keep that rangeland healthy and functioning and doing all these good things like cooling the planet is livestock, and we've in the media over recently have sort of vilified livestock, but it's not the cow, it's the how. That's sort of become the phrase, right? And it's how we manage that cow that causes the negative consequences, not the cow itself.
Right.
They're an intricate and important component of a functioning grassland.
Yeah, grasses and grazers evolved together, huh? If you look at here before, we had huge herds of bison on the plains of Asia. There was arcs and sheep and all kinds of different animals. Africa has, huge diversity in mammals, ruminants. In Australia, there was, I can't remember their names, but there was two big grazers in Australia that the Aboriginal people hunted to extinction about 50,000 years ago. And ever since then, Australia's become fire dependent. So, grazers and grazing were absolutely critical to functioning ecosystems. And that's what kept the planet cool, was that process of re-radiating that heat out by transpiration. So,
yeah. And then now, and this is work that we have some knowledge of through other work that we're doing, is people are using cows in clever ways to actually regreen deserts that have been created
yes.
by overgrazing.
Yes.
And that's incredible, and such a hopeful story that we can turn the certification process around and regreen deserts that were grasslands.
Exactly. The biggest desert in the world, the Sahara, was it's totally man-made. It's so it's incredible how we have screwed up the surface of our planet in the last 10,000 years, and we just need to think about how it functioned before and figure out what we can do to make it function the way it was in the past. And it's not very hard to do, really. We just have to change our thinking a little bit. And so, as you said a minute ago, everybody talks about cows, and oh my God, we're all becoming vegans because it's evil to have a cow. And I guess if the cow is in a confined animal feeding operation, maybe it isn't very good. And cows do emit methane. We all know that. But if that's all we ask, if our context says cows emit methane, yeah, they're bad. But let's look at what else they do. If they create healthy rangeland, they're going to sequester way more carbon, encourage biodiversity, which we all need desperately on our planet. Only a ruminant can do that. So it depends on how you ask the question. I guess that's my whole point of this whole little presentation, is that, when we focus on CO2 or we focus on cows, we totally miss the point. We have to look at the big picture. And just remember that when we talk about cows, that most of the land, there's over 4 billion hectares of rangeland, that it's too rocky, too dry, too topographically challenged to, it can't be anything but a place for ruminants. So we need to encourage ruminants and let them happen and start to regreen the drier areas. So the solutions then are in my thinking, they're natural processes. We aren't changing anything. We're just enhancing and encouraging what was already there that we have destroyed. We just have to ask the right questions, make sure we're focusing on the right things, understand the whole, the big picture. And what the average person can do that lives in a city, well, obviously they can't have a bunch of cows running across their lawn, but every one of us eats every day. And what you purchase in the store or at the farmer's market or however you buy your food makes a difference. I can be the most regenerative farmer in the world, but if nobody will buy the products that I produce, I'm not going to be in business. So we're all in this together. And so educate yourselves, tell other people, about this, do more research, and learn about how this truly works, because as I said at the beginning, we don't have a lot of time. The world is changing rather quickly. The number of species going extinct, things like that. We know the world is warming, all these things are happening. So we have to start doing things relatively quickly. So spread the good news, tell your neighbors. It's every one of us. We're all citizens of this planet. We have to do this. So these are just a few resources that I use that are excellent resources. If you're looking for more information, I'll just list them there. And so I'm just going to close on this little quote. And this comes from a fellow by the name of Roger Savory, and he says, 26 major civilizations have failed due to the collapse of agriculture. How arrogant would we be to presume the root cause of our collapse won't be exactly the same thing? The only difference now is we're doing it on such a huge scale, it might be the end of us if we don't get this right. And I guess I have a bunch of grandchildren coming along, and I guess it's my hope that they have the same kind of opportunities that I've had. So thank you very much for the opportunity, Michael.
Yeah, thank you. It makes me think your final quote here is powerful. And, you know, in the past, when civilizations did fail for one reason or another because of how they were growing food, whether it was overgrazing or erosion or whatever, it wasn't everything, right? You know, the Romans collapsed because of what they did to their, you know, the Aztecs, whatever, right? There's the long list that we know. But like I say, when the Roman Empire fell, did the Aztecs know or care about it? No, because, but now you're right.
We're all
You know,
together now.
it's all kind of interconnected. It's global, and if it fails, it's everything, and it will be much more. Yeah, there'll be a lot of pain and suffering by us all, and so you know there is the talk that these events could be sort of, you know, existential threats to civilization. So we need to take these things seriously and get at it. And that's the hopeful part, is we now have the understanding to get started, where even just like say 5-10 years ago, we didn't really
understand it. No, that's right. That's what's so exciting, is that finally we're starting to understand the big picture and understanding the whole and what we can do without, you know, billions of mega structures and all this kind of stuff. You know, this is all simple stuff that all we have to do is just change a few things. We have to change how we buy stuff. But, you know, it's not hard. We all need to eat. So whether we eat grass fat and beef, or whether we eat industrial fat and beef, you know, it's not that much different. And you know, do our grain production a little bit different and things like that. Use cover crops, intercrops, all these kind of new terms that are coming out, you know, and starting to put that carbon back into the ground, maximize the C and minimize the B. That's it in a nutshell.
Right. And it's kind of the other disciplines that are kind of leaking into agriculture, like ecology and soil biology and all these good things that are helping us to kind of put it all together and to understand, like you say, the whole. It's this sort of big interconnected, all the parts are interconnected, and you can't just look at one piece of this puzzle. You have to sort of put it all together. And that's where things like ecology and complex systems theory and all that becomes, you know, just very, very important and necessary. And that, yeah, we now have, is there much to learn? Absolutely. But I think we now have enough to really make a good start on this.
And it'll just get refined, and we'll get better at it as we start to do more. You know, it will become mainstream, and, you know, the innovativeness of farmers is absolutely astounding. Once they understand what the problem is, they are incredibly ingenious, and, you know, they're wonderful, you know, incredible people to work with their hands and tools and things like that to make things better once it's understood what the problem really is. And I think we're just about there.
Yeah, and you and I are fortunate to be able to work with many producers and see that part of what results from this deeper understanding is there's so much creativity and imagination that can now be applied to agriculture that I think maybe has been missing. We've kind of adopted these sort of simple recipe-based kind of systems, and then, you know, it's not to say that those haven't been useful in certain ways, but there are consequences to that too. But just to be able to inject some of that creativity is exciting too, because that's part of being human.
Yeah, we've been really good at putting band-aids on problems, and we haven't really looked for the root cause of the issue.
Right. Yeah. Address symptoms, and then things just continue to kind of get worse and worse instead of getting down to that root cause and solving the problem at that sort of deep systemic level. And it's the same with our health, right? You know, if you want to solve the problem, you got to really get at the real problem, not the symptom, right? You know, you got a headache, it may not just be so easily solved as like taking a Tylenol, right? You got to
Yeah.
kind of figure out why your head is hurting.
Causing it. Yeah.
You continue to bang your head against the wall. The Tylenol ain't gonna help too much. But anyways, yeah. So thanks a lot, Blain, for this. And this is for the Manitoba Grazing Clubs, and we'll get it posted on the website on YouTube, and it'll be there for everyone to have a look and give people a chance to think. And we're always here to answer questions, so you can contact either of us, and we'll try to help you make your farm better.
Take care.
Great.
Good luck, everyone. Enjoy the journey.